Hey everybody, welcome to the Cybernetters UNIX Linux Administration course. I'm Andrew Yek, and in this course we're going to dive deeper into the fundamentals of Unix Linux system administration, covering everything from installation and management to scripting and automation. So, as you're probably wondering, this isn't just a lecture-based course, but you can expect live demonstrations, hands-on labs, and real-world scenarios to help you gain practical experience with Linux systems. Whether you're looking to build a career in system administration or you just want to strengthen your Linux skills, this course would just give you the tools you need. So you may be wondering, what are we going to cover in this course? So some things we're going to cover in this course are the core Unix and Linux concepts such as the history, system architecture, and administration roles. We're going to go into the installation and file system management, which includes the disk partitioning, file permissions, and LVM. Networking and system services, which is configuring IP addresses, firewalls, and network troubleshooting. We will also go through some of the users and process management, such as creating users, managing processes, and handling system resources. Security and SC Linux, which is the hardening the Linux systems, access controls, and monitoring. We'll also go through shell scripting and automation, which is like writing bash scripts using loops, conditionals, and regular expressions. Software management, which you will be able to manage packets, compile applications, and manage dependency. And lastly, we'll be going over file sharing and remote access and trying to set up NFS, Samba, SSH, and system backups and all of that. So by the end of this course, you have a more solid foundation in Linux system administration, and you'll be ready to manage servers, automate tasks, and troubleshoot real-world issues like a pro. So let's get started. So let's talk about a bit about Unix before diving into the fundamentals. So Unix isn't just a single operating system, but rather it's a collection of related operating systems that share common principles and design. So over time, Unix has evolved into different versions, but it primarily falls into these two major divisions. The first one is BSD, also known as Berkeley Standard Distribution, which is developed at UC Berkeley. BSD includes key advancement like the TCP/IP networking stack, and it makes a foundation for modern operating systems like macOS and FreeBSD. You also you also have the SVR4 or System V Release 4. It is created by AT&T, and SVR4 focus on enterprise environment, which brings in features like system administration tools and improved memory management and compatibility across hardware platforms. Let's talk about the birth of Linux, which is deeply connected to the evolution of computing in Unix. So let's take a quick journey through history and see how it got here. So it all started with the system operators in the 1950s, which managed the first commercial computers. As computing advanced, we saw the rise of time-sharing system in the 1960s, and time-sharing systems allowed multiple users to share a single computer's processing power efficiently. Then came the dawn of Unix, 1969 to 1973, which was a major turning point in where developers focused on writing small, modular programs that work together. The philosophy made Unix a powerful and flexible system. By the 70s and 80s, Unix dominated, which led to the development of BSD with support from DARPA. However, the 90s brought competition. Windows NT became a dominant force, forcing many Unix admins to adapt. But Linux was born during this period. Linus Torvalds created the Linux kernel in 1991 alongside the GNU Project, which provided essential open source tools. Fast forward to today, we're in the resurgence of Unix and Linux. Companies worldwide has embraced Linux because of its cost-effective, powerful, and open source, which makes it a critical player in modern computing. So as computing systems became more general purpose, the need for specialized skills grew. This led to the rise of system administrators. So unlike early computing where a single operator was enough, modern Unix systems require dedicated professionals to manage a wide range of applications and users. System administrators did not just maintain systems, they developed processes, standards, and best practices to ensure stability, security, and efficiency. In order to support this growing field, formal training and documentation became important. In 1987, the U.S. Unix Association held its first conference focused on system administration, which brought professionals together to share knowledge. By the 90s, the SANS Institute was founded, further advancing training in security auditing and network administration. Being a system administrator is more than just keeping servers running. It's about ensuring stability, security, and efficiency across an entire IT environment. Systems manage user access, automate tasks, oversee backups, and install software to keep systems up to date. They also handle monitoring and troubleshooting, making sure everything runs smoothly and responding quickly when issues arise. Security is also another critical responsibility. Sysadmins proactively monitor for threats, fine-tune performance, and enforce policies to protect the system. They also work with vendors, maintain documentation, and sometimes just put out fires, both figuratively and literally. At the end of the day, system administrators are the backbone of IT, ensuring everything stays operational and secure. So Linux comes in many flavors, also known as distributions or distros, each designed for different use cases. Red Hat is the most successful, and it's widely used in enterprise environments because of its stability and support. Fedora is Red Hat's cutting edge counterpart, which is great, especially for testing new features. Debian is also known for its reliability and serves as the foundation for many distros, including Ubuntu, which is the most user-friendly and widely adopted Linux distributions. SUSE, Linux Enterprise, and OpenSUSE are popular for enterprise and community-driven use, with a strong focus on security and performance. Each distro has its strengths, but they all share the same Linux core, which makes Linux an incredibly versatile operating system. So that wraps up our introduction to Unix. We explored its history, key philosophies, and how it laid the foundation for modern computing. As we move forward in this course, expect live demos, hands-on labs, and real-world examples to help you gain practical Unix and Linux skills. We'll dive deeper into system administration, networking, security, and automation, all essential for managing and optimizing Unix-based systems. Thanks for watching and as always, stay secure and keep learning with Cybernetters.